let me pose a question to you. Let us say I have a material. I'm just going to show a cartoon of it. And let's say this is one of the weak planes. As we have examined, if there is a compressive stress or a tensile stress that is applied, since this is a weak plane, the critically resolved shear stress will be responsible for the movement along this plane once this tau result is greater than a particular limit, right? Now, the question that I am going to pose is, let us say this is one of the weak plane number 1. Let us say there is another weak plane like this, weak plane number 2. There could be one more which is weak plane number 3. There could be one more like this, 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 one more like this. Let us say, and let us say innumerable weak planes. The question that I am going to ask is, for what stress will this material fail? When I say fail, it means that it will start to have permanent deformation or yielding. So the question that I am asking is, when will it yield? At what stress level will it yield? That's the question. Let's try and answer that question. Let us examine a simpler case in order to answer that question. A simpler case could be, let us say there is a solid subjected to a stress. I'm just showing it as compressive stress. It could be any other stress. And let's say this is XY axis. I'm just showing in a two-dimensional regime. This, let us say, is a weak plane, okay, at an angle theta with respect to x-axis. Now, in order to find out when this particular solid will fail, I will find out the tau result and equate it to tau critical in order to get the answer, right? But let us say, apart from this weak plane, which has a limit of tau critical, there is one more plane, okay, which is, let's say, something like this, which is at an angle that is, so let's say theta prime greater than theta, just for the sake of argument. Now, the question I have is, along which plane, let us say the critical value of shear along with which this particular plane will yield is, let's say, tau critical, which is the same as this. Now, my question is, will it shear along this plane or will it shear along this plane? What is going to be my answer? Well, that's not very difficult for me. I'll find out this. Let me call this as 1, tau resolved 1, and let's say this is tau resolved 2. Now, if tau 1 resolved is less than tau 2 resolved, for this same stress, tau 2 resolved will go to this value tau critical faster than this tau 1 resolved, which means that this will be the plane along which it will fail. What does this mean? If tau 2 resolved is greater than tau 1 resolved for the same stress level sigma that has been applied, then tau 2 resolved becomes the critical one, right? So, what are we looking at? Suppose of the two planes, which one has the higher shear stress, and that higher shear stress should go to the limit in order for this to fail. So far, okay? Now I am going to pose the previous question, which is, there are lots of planes. There are lots of planes within the 360 degree rotation. Many planes exist. In that case, what should I do? Well, I will find out tau 1 resolved, tau 2 resolved, tau 3 resolved, tau 4 resolved, and so on, right? I will find out tau 1 resolved, tau 2 resolved, and so on, tau n resolved, and this n could even go to a very large value. Okay. In that case, I will look for maximum of all this. Yes or no? And if I find the maximum of this and set it equal to tau critical, I have the answer for when it will fail. Yes or no? So for a material that has innumerable planes along which it can fail, I can state that if I can find out the maximum shear stress for the stress that has been applied along a particular along that particular direction, and when that maximum goes to a critical limit, the material will yield. This was proposed by Tresca. Let me rephrase this statement as tau max for a given stress condition. I'm going to now use stress tensor. If I am able to find out the maximum shear stress, and if this is equal to tau critical, which is due to Tresca, then yielding occurs. Right? Now, we'll look at this separately as to how this could occur. If I look at some of these materials that I showed you, let us say the metal. Metal is a polycrystalline material. Do you know when he proposed this? Tresca proposed this kind of theory with so much insight 150 years ago, more than 150 years ago. He proposed this in 1864, long back. He had an insight that this could be the best way by which I can describe failure. Because in those days, they had this metal forming that was coming up in the Industrial Revolution. And somebody had to look at when this kind of failure, yielding, would occur. Right? Yielding produces permanent deformation, and therefore I can shape the materials. Right? And therefore, Tresca conducted lots of experiments and finally concluded that this could be a good way by which one could explain when permanent deformation can occur. If you look at this, I need to find out the maximum shear stress. Okay. How do I find out the maximum shear stress for a given stress is one question that has to be answered. Alright. Once we answer that, this is a way to explain when yielding will start. When yielding will start means onset of yielding. Let's take an example and examine this particular condition by Tresca. If I find out the tau max of this sigma and this goes to a critical value, that's the property of the material, then yielding would occur. Right? Now, let's look at how to find out tau critical, which is the property of the material. Right? Okay. I need to conduct a test. Let's say I conduct a tension test. I apply a tensile stress sigma to a bar like this, and this is a ductile material. What could happen? At a particular value of this stress, it will start to yield. Let yield occur. I can say yield or onset of yield occur at sigma y value. Okay. So when I apply the stress sigma y here, it will start to yield, let us say. Now let's examine this particular condition now. I need to find out tau max for this stress. Right? And this stress is now reaching sigma y. I want to find out the maximum for this particular sigma y. How does it occur? It occurs at a 45-degree angle We examined this earlier at a 45-degree angle, and this particular shear is responsible for permanent deformation. Okay. What is the value of this? This is the maximum, and that is equal to, from what we did earlier, is equal to sigma y by 2. Or in other words, if this is equal to tau critical, yielding has occurred, or another way of putting it is sigma y is equal to twice tau critical. Okay. Now I can use this, insert it over here for this material for a tensile test, and say this is equal to, tau critical is equal to sigma y by 2. What does this mean? This is the material property. If I want to find out the yielding of this material for a general stress, I am now going to call it as general stress. For a general stress, if I find out the tau max and that goes to a value sigma y by 2, then yielding will occur. And this is, my friends, is the Tresca condition that he proposed 150 years ago. One of the best known conditions that have been proposed for onset of yielding. Even today people use it, engineers use it, most popularly used.